Hey everyone. Okay, so I want to do this short video looking at RC servos. We've all seen the pulse patterns that go into an RC servo to control it from, say, a microcontroller. But at least for myself, I haven't seen what the output is from an H-bridge. And why this is interesting is, like, in respect to the servo that I'm trying to build, I need to figure out, well, how does it step at such small increments, A, and B, how does it shoot across greater distances and then arrive precisely at the intended position, without overshooting? So that's what I want to look at. So I hooked an RC servo up to my oscilloscope here. Let's check it out. Here are the leads attached to the two terminals of the motor. And let's just turn it on here. Okay, what do we got? We have shooting in the clockwise direction, and then a slower stepping through each degree counterclockwise. So what does this look like on the scope? Let me zoom out. Come on, baby. There we go. Okay, this is the shooting. You know, across whatever, 100 degrees there. And this is the stepping. And as you might expect, this is a kind of pulse width pattern. So let's just stop this and have a look more closely. Okay, right there. And I'll shut off the noise. Okay, let's zoom in here. Let's see what the pulse pattern looks like. And what you can see is this is 1 millisecond per division. And so these pulses are about anywhere from, half a millisecond to a millisecond long. And the off period, the off length is about a millisecond or a millisecond and a half. Okay, so that should be easy enough to replicate with a microcontroller to going into an H-bridge as a first attempt to get stepping working. And what about this shooting from one position to another? So this is 100 degrees. The H-bridge is clearly the FETs are set in a certain direction, and it just stays there in that direction until it gets close to the destination. And then the pattern gets interesting again. We see that zoom in a little more. We see that the motor it starts to be pulsed off for increasingly long amounts of time. And I can only assume that this is braking, not coasting. I'm not sure yet. Maybe I'll hook up specifically to the outputs of the FET to find out, of each FET to find out. And then, anyways, so at least it's being deactivated in increasingly, it's being deactivated more and more until it arrives at the position and then it's off. So I should be able to replicate that as well. Well, that's good enough for now as a starting point. And that appears to be the pattern that goes into control a DC servo, hobby RC DC servo anyways.